For the number of total complex zeros, we just need the degree of the polynomial. Okay, the total number of zeros is just the degree for any polynomial. That's the fundamental theorem of algebra that gives us that. So there are, well, 3 total complex zeros. Now it's important to remember here that a complex number, that actually takes into account all numbers, right? A real number is still a complex number. It's just a complex number whose imaginary part is 0. So every number is a complex number. Now this breaks down into real and non-real zeros. And so we're going to have a certain number of real and a certain number of non-real. So to get that, we're going to go and find the zeros of this polynomial. So we take our polynomial and we set it equal to 0. And we can factor this if we can factor this by grouping. Okay, notice we can pull an x squared out of that first group. We're left with x minus 6. And this one, we can't really pull anything out of that, so we'll just leave that as x minus 6, but I'll go ahead and write in parentheses, so it's grouped. I'm going to go ahead and write out the coefficient of 1 there, just so that we see that. That'll help us at our next step, where we see the x minus 1 in common, x minus 6 in common, so we can pull that out. And we're left with x squared plus 1. Well, x squared plus 1 is irreducible. So this gives us x equals 6. So there's a real 0. But x squared plus 1, if we set that x squared plus 1 equals 0, if we solve for x here, we subtract 1. And then to take the square root here, well, the square root of negative 1 is plus or minus I. So there are 2 non-real zeros and 1 real 0. So 1 real and 2 non-real.